Okay, in this video, what we're going to do is continue on with our discussion of textures that we visited in the last video.
In an applied example.
That's right. It's time for a little application. Now, we're going to continue with the SDL demo that we did for you guys earlier, where we have a simple rotating cube. As a matter of fact, Joel, if you could bring that super groovy cube up. Look at that.
It's our cube.
Yeah, except for it's got some bland colors on all of our faces.
Right.
And we need to replace those with a texture. Let's go ahead and close the application and show them that texture.
So if we come under here and just double click on him.
Look at that texture. It is the texture begging to be placed on that cube.
Yes, it is.
So we are going to show you guys how to set it up in our application to facilitate that. But we're going to do it in a very efficient manner.
Right.
We're going to create a texture class that is going to handle most everything dealing with the texture itself.
Right. In fact, we only need to add about 6 lines of code.
Yeah, to our application itself.
Exactly.
So the nice thing about this is...
Besides the GL text cord stuff.
Of course. The nice thing about this is we can just simply use this texture class in any application we write.
Yep.
And unfortunately, it's set up only to handle a simple TGA file.
Right.
A simple one. And I say unfortunately...
A simple uncompressed TGA.
That's right. I say unfortunately only because it would take a lot of time for us to go in there and to put more involved algorithms in place to handle decompression and things like that.
Hundreds of lines of code.
Yes, and there's no reason for that.
That goes way beyond the scope.
That's right. So once we get done, it'll be a very basic texture class, but it'll handle its job nicely, and it'll be able to work for us in the upcoming videos that we've got planned.
Right. Basically, it's an interface into OpenGL so that we don't have to worry about the function calls for texture handling.
That's right. Now, you guys, of course, can take this texture class and expand on it.
Yep.
And you can put calls in that basically wrap around other libraries.
Exactly. That's what I was about to say.
For importing anything that you'd like. And then you're really set. You just dump this in your application. Woo, you got complete support. So with that, let's go ahead and jump back over to .NET, and let's add some new files.
Yep, so let's go here and add a source file, and we'll just call this guy texture. And we'll go ahead and create our header file as well. So texture.h. Let me just add a few things into our header file real quick.
Kind of your standards.
Yeah, your standard.
If not defined, just so you know, we don't end up trying to define this more than once.
Right.
No good.
And so there we have it. And let me just quickly block in our class texture here.
Don't forget the Terminator. Terminator, thank you.
You're welcome. So there we have our class texture. And let me just include, remember, we're calling OpenGL functions here.
That's right.
So let me just copy and paste the same things that we have here, just this bit of code right here.
Right, because really over here in the header file, we're not accessing the GL or GLU headers or libraries anywhere. So this is kind of like a standalone guide that you can easily bring into any of your applications. And what's going to happen is we're about to start doing all sorts of OpenGL calls in here, and without including the GL and GLU headers, it's not going to have any clue what we're talking about.
That's
You're going to end up with a list of errors that's about 3 miles long.
And that's not good.
No.
So let's go ahead and block in our constructor and destructor as well. So let's define our public section.
Okay.
And then we have our texture. And we're going to have 2 arguments here, basically a file name and a name. The file name is going to point where the texture is, and then a name is simply to identify what kind of a name for the texture, if you will, so that we can use it in any case that we want to. Let's say maybe we have our wood texture and we want to display it to the user with a more user-friendly name.
Right.
So we'll pass it a string file name. And a string name, and we'll just default that to blank, because sometimes people may not want to have to define a name.
Right.
And of course, because we're using string, let's come up here and just include our string.
Well, you are all over this.
And then make sure we say using std string. And let's add our destructor in here. And there's our main guys. Now we do have a few variables that we need to define for our texture class. So let's go ahead and block these in as well. So I'm just going to define a separate section for variables. Let me just slide this as variables, member variables. And here we just have our member functions. Just a nice way to differentiate everything.
Sure.
So, of course, we're going to have our image data.
Yeah, this is the big thing that we talked about in the last video. Remember when I drew the arrow in Photoshop saying, now we're going to run out and do our own code where we're going to handle, in whichever manner we'd like, getting that raw data.
Right, and then creating memory for it and then putting the memory into it.
And that's what we're setting up right here.
Yep. And we're also going to need to store our bits per pixel, so we'll just call that BPP. We'll see how to... Oh, wait, well,
So
one
I
side
think
car.
that's an unsigned int. Yeah.
Just saw it above it, and I had
That's
to
all
copy
good.
it. Yeah.
A width and a height.
Yep. Of course, we need a width and a height.
Yeah, go ahead and tab over the
Yeah, I will.
BPP just to make it look a little nicer.
And we'll do this
Yeah.
as well. Yeah,
Excellent.
much better. And as we mentioned before, for our bind texture, we're going to have to get our text ID. So let's just put this in here. And you'll notice I'm declaring all of these as public. This is just for simple access, kind of like when we did that other class. Which one was it?
The vector one.
The vector one,
Yeah,
exactly.
where we just made X, Y, and Z easily accessible.
Exactly. And the same idea goes here, because when we call our bind texture, we'll simply access this member variable.
That's right.
And pass that into our GL bind texture. And we'll also have our string name. So let's just put that in here. And now for some private member functions that we need. We'll need a function that will load our TGA.
Right.
Of course, if you want to, this is where you can kind of add in other functions, if you will.
Absolutely.
Load JPEG,
BMP,
load BMP.
JPEG, etc.
Yep.
And we're going to go ahead and set this up as a return type of bool.
Right, just so that we can return whether or not it successfully
exactly.
loaded the TGA. And we'll just, of course, pass it the file name as well. And we'll have another one that creates the actual texture. So basically, at the end of load TGA, you'll call create texture, which will do all the OpenGL calls.
That's right.
The create image, the create 2D image, etc. So we'll have create texture. And in here, it's kind of the same as what you pass to the OpenGL call.
Mm-hmm.
You're going to pass it the image data. So image data, the width and the height, and then the type that it is.
Right.
So like RGB, RGBA, etc. Is that right? Okay. And let's see. So that's the main thing. Also, we're going to keep a global track of all the textures that are created. So we're going to create a static variable that allows us to hold every single texture that we create, and then we can remove it later. Mm-hmm. So just to have a global access point for all our textures. So we'll create a static vector that holds texture pointers, and we'll just call this textures. And of course, again, we're using vector. So let's come up here and include our vector.
And this is not the vector class that we created.
No. This is an array, if you will, that allows us to remove items and access it using, the brackets that we're used to. So include using std vector. So with that, let's go over into our texture source file here real quick. And let's start implementing some of these functions that we created. So the first thing, of course, is we need to include our texture.h.
That's right.
It's kind of important. Kind of. And we declared a static function, static variable. So let's go ahead and initialize that. So textures.
Mm-hmm.
And our constructor. Actually, let me go back into my header real quick and just copy and paste these over here. So don't mess any of this up. So we have our texture.
Get rid of the terminate as.
Terminators go away. And default values go away. All right. So what do? In our constructor, we're going to actually call the load TGA.
Which makes sense.
Yes. So we're going to load TGA, and we'll just pass this. Actually, because we do, if you come back over to the header file real quick here, we do have a name. And if we come back into here, this is name as well, so that can be kind of confusing.
Right.
So let's just add an in to both of these, just to kind of make it...
Just for clarity's sake.
Just for clarity. And come down to our load TGA and pass it in file name. And we'll set name equal to in name. And let's see, we'll also push this instance of our texture onto the textures vector list. Let me not do that. So textures.pushback, and then we're going to just send it this.
Right.
So that is basically our constructor. Now for our destructor, we only have one thing that we really need to clean up.
Yeah, let's definitely go ahead and get that in now.
Yeah, because I typically forget this. Remember, we're going to allocate our own memory with our image data because we're loading it manually and all. So we need to go ahead and delete that after we're done. So delete image data. In fact, let's come into here at the very top and set image data equal to null so that we initialize it.
Absolutely.
And then here, make sure that we do actually have something to delete. So image data. If there's something to delete, go ahead and delete it. Also, once we're done with our textures from once this destructor is called, we no longer want it in our textures vector. So let's go ahead and delete that. So let's create a for loop that iterates through this entire list looking for us. So we simply do a vector texture pointer and create an iterator, which is called it, and start out with textures.begin. If you've worked with lists before, this is very, very similar.
Well, we covered this in VTM number 3 pretty heavily.
Yeah. So if it does not equal textures.end, simply
just
it
keep
plus
walking
plus.
through it, yeah.
And if
it's equal to us or this.
Yep. Then let's go ahead and delete it.
Yeah.
So textures.erase it. And we're done.
Cool.
So that's the two main ones. Now we need to kind of put in our load TGA and create texture. So if I go back into texture.h, let me just copy these two. I have a tendency of messing up the function definition, so no harm done in just copy and pasting. And then add in our texture : so we know who we're associated with. And now it's time to implement our load TGA.
Which means that we first need to have an understanding of the format of the TGA file.
That's right. In this one, we need to understand the header part of the TGA, where the image data is actually stored, et cetera, et cetera.
Exactly.
So to do this, I went to watsit.org and looked for their specifications for TGA.
Pull up the website
so let me go over to here.
Just so you guys can see the website we're at.
So www.wotsit.org. Excellent website that contains all sorts of specifications for 3D graphics files, regular graphics files, etc., and search for TGA and download a TGA file format specification version 2.0. And then this is what I got. So if I come over to here, a nice long 26-page specification.
With a lot of really good stuff in there.
Yes, very, very good. And just by following this, I was able to quickly be able to load an uncompressed TGA file.
Right.
So if I just come down, I'll show you some of the header information that we need. And this is kind of useful. Make sure that you understand this. A long is 32-bit, short is 16-bit, byte is 8-bit. This is going to be really useful when you're getting the header file because it needs to be exactly the right size. So if I just come down, notice the TGA file format is divided into various sections. So we have our TGA file header, which is all of these, basically 18 bytes. Stores all the information that we need, the width, the height of the picture, the format, etc. And then comes our image/color map data. So all the information that we need is going to be stored right here. We're going to load in from the file all the image data. Because it's uncompressed, we don't need to do any other manipulation to that data.
Right. And we are, of course, going to verify that the file type is legit, that we're looking for. Because if we do have compression involved, etc.
Right, it can get messy.
Yeah, it can get messy quick.
Yeah. So the first thing is ID length. So basically, in this process, in our header file, we're going to create a struct that basically holds our TGA header. And we're going to read it in from the file and start checking all the header information and preparing it. Get the width, the height, as I said. So what does the header file look like? We have an ID length, 1 byte, color map type, which is 2 bytes. So if there's a color map, specify it here. Image type, field 3, which is 1 byte. Notice 2, image type 2, is an uncompressed true color image. And this is what we're looking for. So inside of our load TGA, we're going to actually check, is the image type uncompressed? If not, we can't handle it and exit.
That's right, because we don't have the supporting code there.
Exactly.
But from this document, you can gather the information needed to have that supporting code.
Yep, if you wanted to.
For sure.
And then we have our color map specification, 5 bytes. In this case, it's going to be 0 for us. Go all the way down. We have our image specification, and these bytes are very, very important. We have our X origin, our Y origin, and then our width and our height of our image. Very, very important. Our pixel depth. In this case, we'll support 24 and 32-bit color.
Right.
And then our image descriptor, if there's anything extra there we need. And let's see, I think there's a few more. No, that's it. This is the image color map data area. And that's where we're going to read in all the uncompressed information about our TGA. So if we come back into our SDL demo, that's just to kind of give you an idea of where we're going with this. So in our texture.h, we actually need to create a struct. And we're going to simply call it a TGA header. And that's going to contain all the information we found in that PDF. So we can just come in here and create a struct TGA header. And the first thing was a byte, 8 bits, called ID length. We're not going to be using this, but when we load from the file, the number of bytes for our header needs to be right so that we can be at the right location when we read in all the uncompressed data.
That's right.
Then we have our GLU byte, and that's going to be our color map type. Again, in this case, we don't need to worry about this one. And then we have another one. This is going to be our image type, which needs to be 2.
Right.
And then we have
color map specification.
Our color map specification.
With 5 elements.
5 bytes. Just like to make sure everything's right here.
Right.
Our GL short, which is 2 bytes. For our X origin, and for our Y origin, image width and image height. So our image width and our image height. And finally, another GLU byte.
For our pixel depth.
Yep. So there you have it. There we have our TGA header. Now all we have to do is go back into our texture.cpp, load this file, or whatever's passed into us, and read in the TGA header information. So let's create a local TGA header. Now we'll just call this TGA header. And this is where we're going to load all our information into. Actually, just to make it clear, I'll lowercase that. So we'll use file streams in this case, just to make it easier on us. So an IF stream. And we'll pass it our file name .data because it needs a character pointer. So we pass it a character pointer. And then we need to specify that we want to load this file as a binary file. By default, everything is loaded as text.
That's right. This is very important.
Right. If you
mess this up, fail to do this.
Right. You could run into some serious problems. It will not load certain characters and so on. So make sure you type this in correctly. So we have our std iOS base. This is specifying a namespace. And then inside this namespace, we have a type called binary.
Right.
And this could be text or whatever. In this case, definitely make it binary. And while I'm at it, I might as well go ahead and go to my texture.h and specify that I'm going to be using file streams. Because this is, again, very, very important. If you don't specify it, well, it won't work. It won't compile. So we're including fstream, and we're going to be using std ifstream. Just while I mention it. So at this point, we've loaded in the file. Now we need to make sure the file is open. Open properly. So let's see. File is open. If it didn't open properly, just go ahead and return false. Remember, true means that we properly loaded the file, and false is going to mean that something went wrong, so just return false. Now we need to read in our actual header information. So let's do let me just do this. File.read. And you'll notice we need to pass a pointer to a string, and then how many items do we want to read? Well, this is easy. All we need to do is pass it a pointer to our TGA header. So ampersand TGA header, and then the size of it. So size of TGA header. But this is going to need to be converted to a character pointer, simply because we need to typecast it. Otherwise, it'll generate an error. And we also want to make sure this worked properly. So we can do an if this did not succeed. Go ahead and return false. Something didn't work. Then
obviously we're kind of leaving out, some sort of error.
Error
to let
message.
The user know exactly what went wrong. Just keep that in mind.
Yeah, if this is something that you're starting to run into a lot of problems, go ahead and throw maybe a message out to the user, write it out to an error log or something.
Precisely.
Now, at this point, we've read in our header. So if we go back to our texture.h, at this point, we should know everything that's in this header file. So the width, the height, the origin, the image type, etc. The first thing
is verify that this image is one we can work with.
Right. So we'll do it if TGA header.image type, image type, thank you.
If it's not equal to 2,
then this is something we can't handle.
That's right.
So just return false. And again, as Buzz mentioned, we could go ahead and send a message out to the error log saying, this is unsupported type.
Right.
So return an error. And of course, at this point, if this was a JPEG or something, or some file we don't support, this would probably be some totally random number. So even if it was something that we couldn't handle at all, like another format, it would get caught by this as well.
Right.
All right, so we've got that. Let's go ahead and set our local variables, our local width, to TGA headers width, image width. and our height equal to our TGA header.image height. And let's go ahead and set the bits per pixel to what is stored in the header as well. And this is just kind of extracting the information we need out of here. So we've got the width, we've got the height, we've got the bits per pixel. So now we need to check and see if this is right.
Yeah, we can make sure that we do have a width, we do have a height, and that our bits per pixel's 24
or 32.
Or 32. That's right.
Right, so we can do a simple check here. If width is less than or equal to 0, something is terribly wrong. You cannot have an image that is less
corrupt.
than 0. Exactly.
And same thing for height. But you go and throw that 0 in for height.
Oh, thank you. If it's less than or equal to blank.
Blank.
And we'll check if the BPP does not equal 24 and the BPP does not equal 32.
And it's some format we don't support.
Exactly.
Some color depth we don't support.
So we'll return false in this case as well. So we've got all of that. Now, let's go ahead and create the allocate the memory for our TGA so we can actually read in the uncompressed data. So let's go ahead and say image. Let's actually create a local variable that will store the size in bytes that we need to allocate for our particular uncompressed image. So we know the width, we know the height, we know how many bits are required to create for each pixel, right? So we can simply say width multiplied by height multiplied by the number of bytes, and we've got our final result. But remember, this is in bits per pixel. Bits per pixel. So we need to divide this by 8 so that we can get the number of bytes.
Right.
So let's go ahead and create a real simple local variable, simple local variable called bytes per second.
It's very big.
And we'll just equate this to BPP divided by 8. And that's it. And then we need to create another local variable called image size. And this is going to hold the number of the size in bytes that are required for our image. So this is easy. Width times height times bytes per pixel.
Make sure you understand what he just said. This is the amount of memory that's required for. This is the size of it all.
Exactly. So at this point, we know the amount of bytes that we need. Let's go ahead and allocate it. So we simply do our image data equals new GLU byte and simply pass it image size.
If you was worried about a difference there, Joel, it's just at the very beginning of this function, that's where we set up those variables.
Okay, yeah.
But it's all good.
It's all good. So at this point, we need to make sure that if this number of memory was actually allocated. Because if this is a lot of memory to allocate, if you have a 1024 by 1024 image, it could easily stack up to a large amount of memory.
True. There is one thing you might that you might want to add in there, and that's the type.
Okay, let's go ahead and
just so we know the difference if it's RGB or RGBA.
So let's create a GLU int of type. Just really quick.
And we'll just go ahead and set it to default of GL
RGBA.
RGBA, yeah.
Right, and we can do a simple test. We can do it right here, in fact.
Just get it out of the way.
If BPP is equal to 24, then we don't have an extra channel for alpha.
Right.
So we can simply set type equal to GL RGB.
Good. So that's just out of the way.
Yeah, out of the way.
Awesome.
So we've allocated our image data, or have we? So let's go ahead and test. So if image data equals no, something obviously went wrong, so return false. So we're out of memory, apparently. So we've got everything allocated.
We've made it to here.
We need to start reading in our data. And this is really simple. We'll do a file.read, much like we did for reading in our header. In this case, we'll pass it our character pointer to our image data. And then simply pass it how much we want to read. Well, we already know, image size. And let's make sure this works, so we can do an if it didn't work, return false. Oh,
but
actually,
we need to go ahead and free up the memory here.
Exactly. So let's go ahead and...
Otherwise, memory leak.
Yeah, and that's never good. Basically, what's going to happen here... Yeah, okay.
Image data.
Yeah. Image size. Delete image size. Delete image data and return false.
Yeah, cool.
Awesome.
So the bottom line is if something went horribly wrong there, let's go ahead and give that memory back.
Yeah, because anything that happens after this point, we've allocated a large chunk of data.
Absolutely.
So might as well make sure we get rid of that data. All right, so now there's one other thing that we need to be aware of when working with TGAs.
And this is the coolest thing. And this, you would pick up on this real quick if you read through the TGA format.
Yep.
And that's just basically that RGB is backwards.
Yes,
it's
it is.
BGR.
Right.
That's the way it's stored inside the TGA file.
Exactly. So if you mix this up, your textures are going to look weird.
If you don't swap it, you'll still see the image, but your colors are going to be distorted.
Very much so. So this is an easy fix. Simply loop through all image data pixels and swap around
flip
the two.
your R and your B.
Exactly. So let's do a quick loop. So and we'll just do a GLU. And notice I'm using all OpenGL types here just to stay consistent.
Well, plus it's just very good programming if you've got cross-platform in mind.
Yes, it is. And we'll just pass it image size. So we're looping through all of these. And then we're just going to plus equal. Remember, we want to loop through every single pixel. And every single pixel, the size is bytes per pixel. So we just add bytes per pixel. And done. And now inside of here, we're just going, again, we're looping through every single pixel. So first we need to get the R component. Let me just write this down because this kind of makes it really easy to see. BGR, we want to convert this over to RGB.
Right.
So we need to save a temporary variable
of the very first one.
B.
Well, I mean, it's going to be as we progress through each group of RGB. But right now I'm looking at it as I is equal to 0 the very first time through.
Right.
So we're looking at B.
Exactly.
So we need to go ahead and save that out.
Right. So all we need to do is do image data I.
Yeah.
So that's going to be our B component. So we're saving that guy out. Now let's go ahead and swap this last one with this one. So let's do a image data I. Or is that, did I say that right?
That's right.
Okay.
Equals image data I plus 2. We're going to skip right over good old G.
So this guy is now changed to R.
That's right.
And then, since we have B stored, all we need to do is do an image data I plus 2 equals temp.
Beautiful.
And that just converted this over to B.
Yep. And there it is.
So, with that done, all we need to do is create our texture. We need to do the OpenGL commands that are going to, well, allow us to access this texture via OpenGL.
And at this point, if you want to go back and watch the video we had just a second ago, we just finished the previous video. We just finished the section where, if you guys remember, I said that now we're going to jump out over here and we've got our own code that's going to handle getting the raw data.
Yep.
Well, here we are. We've got the raw data now. That's awesome.
So all we need to do is create texture and pass it our image data, our width, our height, and our type.
Which means now we're really just going to need to go ahead and get an ID set up for this guy in OpenGL, bind the texture, set some parameters, and we'll be rocking.
Exactly. And you notice I just throw it in a return true, saying everything works.
Yeah, it's a good idea. Otherwise, you're going to get a warning in the compiler.
And that's not good.
Nah, we don't like warnings.
No. And here's the cool part. We've just written, 84 lines of code.
Yeah.
For our create texture, which is just basically OpenGL calls, all OpenGL calls, in fact. It's very, very simple. Only a few lines of code. The first thing, as we talked about in the previous lesson, create our texture ID. So generate textures. In this case,
sending in one texture.
Right, because our class only handles one texture at a time. So simply generate one and pass it our text ID, a pointer to our text ID. And then once we got that, bind the texture. So basically select the current texture.
And it's going to be the GL texture 2D.
Yep.
And we need to tell it which one, which is going to be text ID.
Which we just generated. And then let's go ahead and create our text image 2D. So our target, well, GL texture 2D.
Yeah, remember I was kind of complaining about this a little bit in the last video where I said, we really kind of know the type by now.
Yeah.
But here we go again. So there's the target.
There's the target. Yep. And then we specify the level. Internal format, that's going to be whatever we pass to create texture, which is type. Our width and our height is passed to us.
So is it RGB, RGBA? Back on type real quick.
Yeah, back on type is RGB or RGBA.
Right.
Which one was this one? Let's see. Let me go back to here. All right. So internal width, height, a border. This allows us to specify. It's kind of funny. It allows us to specify a border around our image if we wanted to in pixels. Not sure why you'd want to do this, but here it is just in case.
Nah, we don't. So, zero will work great.
Format is going to be type again. And then our format is type. Type is equal to... I know, it's weird. Awesome. Is going to be of unsigned byte. And basically what this means is our GL text image 2D needs to know what kind of data our image data is. And in this case, it's an unsigned byte, unsigned char.
Right.
And it needs to know that, otherwise it won't read it properly. Finally, pass it our image data.
Yeah, where is that chunk of memory that contains the raw data?
Exactly. So once this is done, simply return true. Now there is another thing I want to set up before we call this quits. And what we need to do here is set our filters for our textures. And basically, we have two things we need to set. Our minimum filter and our max filter, or mag filter, if you will.
Right.
And this basically says when the texture is smaller than the texture on disk, what should it do? And when it's bigger than the texture on disk, what do you do?
Exactly.
And basically we want to set it to the highest quality. In other words, it will filter it and make it not look pixelated.
The cool thing about what Joel, and you can go ahead and start typing, the cool thing about what Joel's doing is this allows you guys to see that GL text parameter F function called inaction.
Yes.
Where I talked about you could have multiple ones that set several things.
Right. In this case, we're setting just two. The minimum filter. So what happens when it's really small? We'll set this to GL linear.
The other one is not the max filter.
It's the mag filter.
The mag filter.
That's funny to me.
It's funny to me, too.
So our GL text parameter. I knew it was wrong. I just couldn't see where it was. GL text parameter F, and then our min filter and our max filter, our mag filter, and that should be everything.
Very cool.
So at this point, we have our texture.h, so we need to go into our SDL demo and add a few lines of code. Is there anything else?
But before we even go there, we could go ahead and compile just to make sure the header and CPP...
Well, let me include the texture.h just so that I can... Whoa. Include texture.h. Actually, let me include this below this. Just for good measure.
This way we can just...
Wow.
Wow.
I rock.
That was awesome.
So at this point...
now for the simple part.
This is the easy part.
Yeah, we have this new module, if you will, set up. We've got our new class.
Yep.
Now let's put it to good use. Let's bring a texture in and get that texture applied to the faces of our cube.
Right. So let's create a local texture variable utilizing our new class. And we'll just call this texture and we'll set it to null. And in the initialization for OpenGL, we'll go ahead and load it.
Right.
So let me go down to our initGL.
Let's
and
go
there are
ahead
two
and
things
turn
we
it
need
on.
to do.
First, turn it on.
Yes, turn it on. So GL texture 2D.
Now we support textures. At this point, all geometry created must have
textures.
As a matter of fact, I wonder, can you go ahead and compile and run right now? Because
yes.
technically it should work, and you can show them the what it would look like.
Oh, okay.
Oh, well, maybe not. Okay, make a liar out of me. That's okay.
That's okay. It's okay. So let me go ahead and load this texture in. Basically, the reason here is because we didn't do a bind texture. If you tried to bind it to a non-existent one, we would get what we're talking about, like the grayish thing.
Exactly.
So all is good. You're not a liar. So in this case, what we're going to do is create our new texture. So create new texture, and we'll pass it a file name. In this case, we stored it under a data directory, and we called it surface.tg.
Yeah.
And we can give it a name. We'll call it surface texture. Of course, we're not going to use this name, but hey, for good measure.
Yeah, showing you.
Now in our draw scene, so we enable textures, we created our texture, now we actually need to go in here and bind our texture and then set our texture coordinates. We're not going to need these colors anymore, so I'm just going to go in here and delete all these GL colors.
I mean, you can leave them there.
Yep, you can.
They'll just simply tint your texture. I mean, your texture's still going to be applied.
Yeah. So what I'm going to do is just set this to, I'll set it to 111 for now, just so it's a white texture. In other words, you're going to get the natural color of whatever the texture is. No tints applied. All right, so let me go ahead and bind the texture so that I can start utilizing it. So do a GL bind texture, and then pass it GL texture 2D. And the texture, what ID do we use? Remember, we created our texture. This is accessing our texture class.
We had text ID.
And we have our text ID, which was created via our GL gen textures. So there, we've bound the cube. Okay. So now what do we need to do? Well, we need all these vertices have no coordinates on them. Let me go ahead and just compile this and show you what it would look like, because as you can see, isn't it interesting that it has a brown color? I mean, we set the color to white, right? So you'd think we'd get something like that.
But we have that brown color in the texture.
So basically, it's going to access 1 pixel of it because it's using
the entire thing with it.
Exactly. So at this point, what we need to do is set up our GL chords for this guy. So GL text chord to F, and we're going to pass it 1.0F and 1.0F. And let me just copy this line here and paste it a few times.
And you'll
times.
notice the way he's formatting this. Basically, he's got the GL text chord and the GL vertex, both on the same line.
Right.
It just makes it really easy to see, here's the coordinate for this texture. You've just created both of those things. Just kind of cool.
Yeah, very cool. And we're creating this in much the same way that we showed in the video.
Sure. Except you could just copy those 4 lines
Yeah,
and paste
I will.
them all the way down. I mean, it'll have a small drawback, but it'll save us a few minutes. That some of the textures will be upside down.
Right.
But I think everybody will get the point.
Yeah. And we can play with it
maybe
a
the
little
last
bit.
one you can change it up.
Okay.
Make it the 0,2 and all that good stuff. 2.
Yeah, well, let's make sure it works first.
I'm just getting excited, man.
Oh, yeah, I know. So let me just copy this last line. Sorry, a little bit tedious, but it must be done. But as you can see, it's very easy to go in and add texture mapping.
It is.
So we compile that and check it out. Oh yeah, we've got some textures. Some of them backwards, as you can see.
That's awesome.
But
that was to be expected.
Yep.
We haven't gone in there and changed the direction in which we're applying those coordinates. More or
exactly.
less.
Let's go ahead and mess with the top face texture.
Sounds awesome.
So let's exit this, and our top face right here. Let's go ahead and set all of the 1s to 2s. And if you remember
You
from
missed
the did I? Oh yeah, I did. Wow. And check it out. Right now, it's not set to GL clamp because our parameters default to repeat. So what you see is 4 of the exact same texture on the top face.
Do the bottom at 0.5.
All right, so we want to change this bottom guy to 0.5. So we come right here, all the way down to right there, and change the 1.0s to 0.5. And if I compile this and look underneath here,
whoa!
Look at that. You get 1 corner
it's
of
like
our texture.
the quarter of the smiley face I drew in the last video.
Exactly, but better looking.
Yep. Oh, hey, that's not funny.
So there we have it. I mean, it's not too bad now. At this point, if you want to add extra textures into your own 3D worlds, very, very simple. If I just exit this, just to kind of drive it home,
Well,
how
the heart of
easy
it all
this
came.
is.
The heart of it came right there. Texture equals new texture.
We can create texture 1, texture 2, etc.
Yeah, that's what's creating our new object off our class, and
then simply bind it.
yeah,
and then
and do
we're
your
done.
thing. And just remember, in that loop, it needs to get redrawn. So you're going to have all your bindings in there: drawings, bindings, more drawings. You get the idea.
Yeah. In this case, since we only have 1 texture, we could do this elsewhere. But I mean, just once or something like that. But in this case, you know, if you want to have different textures on each face, you're going to need to do this anyway. And this is not very time intensive, so there's no harm done doing that.
Right. So with that, that's going to wrap up this video. Excellent job, Joel.
Thank you. And
we now have a fantastic texture class that we can start using in our bigger application.
Oh, yeah.
Yeah. So with that, that's going to wrap up this video. Thanks a lot.